Good day to you all, and thank you for joining us today. So, well, today we're going to be going straight into chapter 3 of the book. So we're looking at, for those who are just joining us new, the book is Geocomputation with R. So this is what I'm sharing now. And today we're going to be looking at the chapter 3. This is the third month for our study group. So we're going to be looking at this. So to make things faster, I'm not going to be shifting from the book to my R Studio. So I'm going to go directly into R Studio and continue from there. So, okay. So sorry. Let me just take this out. Okay. So firstly, I'm going to load the packages needed for this chapter. So I have all that loaded now. So we're going to be looking at attribute data operations on geospatial data. So the attribute data is non-spatial information associated with geographic or geometry data. So from our previous class or session, from the chapter 1 and 2, we've talked about both the non-spatial aspect as well as the geometry column. So that is what I've broken down to summarize into a simple example. So if we're looking at geographic or geometry data, it contains non-spatial information like the name of a location. I'm going to use an example of Abuja City. So we can also have number like this, that's representing a vector point. So from what we've done in our previous sessions, so this is a point, a vector point that is representing the spatial data for this location. So this is just an example, is just uh, something we have to just come up with. So in SF, so we are representing this in SFC representation. So the latitude is this and the longitude, which represent that location where the Abuja city gate is. So vector attribute manipulation, okay? So the geographic vector data sets are well supported in R. So this is shown in the package, through the package and the SF package. So we're looking at the SF object in particular. So the SF object has a one column per attribute. It can be as many as you want. So in one row per observation or feature, so per bus station or something. So it's more or less like you are looking at a typical data frame. It's not different. The only difference is that this is including a geometry column of class SFC, so which contain a range of geographic entities. It can be single, multi-point, line, polygons, and so on and so forth. So we've done this. You can watch out and check our YouTube channel to watch the previous video for those who are just joining us. So if we look at the SF package, there are so many functions that comes with it. So if we run this function, the methods function help us to get all methods that comes with a package. And in this case, we are looking at the SF package, which we've loaded before. So this is helping us, the package is helping us to look at special features. So that is what we're looking at. Simple features, sorry. So we're looking at simple features that is representing geographical points, maybe multi-line, polygon, whatever. That we're also looking at raster that's going to be treated in the next session. So, but these are geographic data set that we're looking at. So we're going to be looking at the SF package. So if I run this, we're going to get all the functions that are associated with it. And we can see some functions that are kind of we're conversant with when we're dealing with data frame using maybe the dplyr function, the tidyverse package in general. So these are all the functions there. So the next thing that we're going to look at is the geometry column of SF object is typically called geometry or geom, but any name can be used. So just like we do in the normal data manipulation, all you just have to do is this. So we use a function st_sf. For most of the functions in the package, it starts with st, then underscore, then you'll be able to see so many functions as well. So this, if you create a single data frame, okay, and you want to convert it into an SF object. So we use this, the function. So if you want to get more information about the function, you can just st_sf. Okay, so this will bring up the documentation for this. So it creates an SF object. So if we create our data frame by kind of subsetting some data from the world data frame that comes with the package, the this SP data package. Okay, so let's take a look at the data itself. So where am I? Okay, so the data comes in as a simple feature collection. So it has 177 features and 10 fields. Features means rows. So you can check out the data itself. You can see it's typically a table, but it has other types that are attached to it that makes it a simple feature object. So if we subset that and assign the name long from the from this data frame, we're going to have a data frame in this instance. Let me just select that and run. So we have a column like this. Okay, one column, 177 rows. So now we want to add another column, that's the geom column. So selecting this, you'll be able to see that it's a geometry column. So it has multi-polygon. Is a multi-polygon and has so many, that means it has so many points that are attached to that particular row of features. So it's like a map of each country represented by a multi-polygon. So from there, we can use this function, combining the data frame with the geometry column, we'll get an SF object that is a data frame that has a geometry characteristics. So if I run this, so this is going to give us a simple feature collection of two, but with one field. That's that. So I've explained this. I've tried to break down the data frame that we created there. So this is just the breakdown of what I've been talking about since. So and all this. So to explain to you what is embedded inside the entire code on this line. So if you have any questions, then let me know, or you put it in the chat, then I'll be able to explain further. So the SF object that we've been explaining, they have one column. So we have one column per attribute and one row per observation. They also have a geometric column, and they can be extended. So they can also extend the tidyverse classes for data frames. That's why they have this. These other types attached to the SF object that they are having. So exploring the world data set from the SP data package. So if you want to have more information about the data object, so it's an SF object, a simple feature object. It's also a table data frame, a table, and also it has the data frame feature or properties. So if you want to look just like you can do with a data frame, it's almost similar. So we can also get the dimension here. So we have 177 rows and 11 columns. So the function st underscore drop geometry helps us to take out the sticky nature of the geometry column. So we can drop that column and we have a plain data frame. So if you want to read more about this, you have to consult the book. So I'm just kind of summarizing the chapter 3 here now. So the only way you can take out the SF properties or simple features properties from a data frame is by dropping that geometry column. So if I use that now on the world data of the that SF object, we are going to have something different. So now the classes are just restricted to table data frame or table and data frame. The SF property is gone that we saw earlier here is gone. So if I run this again, you'll see that the SF was there, but when we use the function, drops that column. That column is no more there. So if you look at the number of columns now, we're supposed to have 10 instead of 11. So that has been dropped. So vector attribute subsetting. So this is similar to, or maybe a refresher to subsetting in data frame. So it's nothing other than what we do in normal data frame. The only difference is that the sticky situation where the geometry column is still there would always be there. So even if you select columns and you're not selecting that geometry column, you're still going to have it attached, stuck to the subset that you're looking at. So let's just go ahead and look at normal subsetting that we do with data frames. So if I do this, what I'm saying is that I want to return the first 6 rows. So if I go ahead and run that, I'll have 1, 2, 3, 4, 5, 6 rows. So the next statement there is asking for the first 3 columns. The first 3 columns are going to be returned. But if you look carefully at my screen here, you can see it's 177 rows or features and 4 columns. But I'm asking for 3 columns. Right now it's returning 4 columns because of that sticky situation. And if I navigate to the remaining, you'll see that we have the geometry column, which is making the first column instead of 3. So that's the sticky situation we have there. So we can subset normally, but it's always going to just dump itself there. But we're going to show you how you can kind of subset without getting that. So this is basically the first 6 rows and the first 3 columns with the sticky one. So it's still going to be 4. So the same thing goes for this. So we're asking for 2 columns and we're getting 3. The sticky one still going to pop up. So, and we can also use the logical indices and we'll be able to go on and on. So that is basically that. And here we're getting an error because we're referring to an indices that is not available. We only have 11 columns. We're not having up to 888. So that's where the error is. So a demonstration of the utility of using logical vectors for subsetting is shown in the code chunk below. So just like what we have there, so we can have a statement that gives us a logical result, true or false. So this creates a new object, small countries containing nations whose surface area is smaller than 10,000 kilometers square kilometers. I'm sorry. So this is what we're doing here. We're assigning that as a value to a variable by the name I underscore small. So if we look at the summary, we're going to get something like this. The mode is logical, false, 170, true, this, and 2 is 7. So this is telling you that for this logical statement, 170 of the rows that we have is false. So they don't fall into this description, while only 7 falls into this description. So if we take this value and place it into the square brackets where we're supposed to give the rows that we're looking for. So instead of giving indices or a range of rows that we want to return, we are giving this logical statement so that R is going to use that to subset the data. So if I run this, we're going to get only 7 rows and 11 columns because we did not specify anything for the column. So that's after the comma. So that is that. So the short form is this. We can just push in this without saving it as a variable and we'll get the same result. So you can also bring it from small countries. So the same thing. So the example now using some of dplyr functions. So we can, instead of using the normal base-R functions, subsetting that we're using here, we can use dplyr functions on SF object as well. So I can decide to call up only 2 columns, the name underscore long and the pop column. So kindly let me know if you have questions. You're welcome, Hassan. And thank you, Bully, for staying with me so far. So now I'm hoping others will join soon. It's closing hour here in Nigeria, so hopefully by 5 most will be on board. So we can use the select statement to achieve the same thing instead of using the normal R and base R from subsetting statements. So I can do this, run the entire chunk, code chunk, and we'll be able to have this. So if you run only this one, so we have the columns there. So then we also have the SF object itself. Mind you, when we run this, we got 2 columns. But the sticky geometry column would always be there anytime. So you know that you're calling 2 columns, but that sticky friendly geom column would always be there. So just be sure that that's going to be there for now. So that's just it. So every other thing that we're having here is just more or less what we are familiar with in dplyr for normal subsetting or select statements in using the dplyr function. So we're looking at 7 columns. So if you look at use the function names on wall 2 again. So this should give you 1, 2, 3, and all. So with the 8th one being the geom, the sticky one. So name to pop is from name long to pop. So this sticky one will still have to be there. So note, as with equivalent of this, the sticky geometry remains. Select also allows selecting a range of column with the help of the colon operator. So wall 3, the same thing. We can take out some columns using the dash or the exclamation mark. So just just a fun session today. So it's not something too difficult to understand. So just know that whatever knowledge you have with dplyr, with ordinary data frame, you can also do the same thing here. Just know that we have a sticky situation here. So this is also another way of selecting. We just change the name of pop to population. So, okay, let me just bring that up. Word form. So that is it. Instead of pop, we have population. So moving on. So most dplyr verbs return a data frame, but you can extract a single column as a vector with the pull function. Just the same thing as we have in the normal data frame. So if I pull this, we're going to get a vector. This, we get vector. And the same here, get a vector. Okay, so these are the different ways you can get your vector. The slice function, the same thing, is the row equivalent of select statements. So the following code chunk, for example, returns the first 6 rows, selecting the rows 1 to 6. So you can tweak it around. You can decide to say 10 to 16. Anyone, you will get the data there. So filtering the same way as we have it in dplyr. So if you're not so familiar with the tidyverse family of packages, I think these are going to be like an opportunity for you to know that. So the filter function works on rows. So it helps us to kind of get some data based on the fact that, okay, they meet these logical statements. Either it's true for them or it's false. So like we did with what we have here, the subsetting using the base R function here. So instead of using this statement, we can use the filter statement or the function to get the same result. So, and that is what is happening here. So filter this, and another example is this one with less than. Let me just bring. A small area. So word 7. Okay, so that is going to give us all values. Let's look at area underscore kilometer square. So these are less than, they are all less than what? 10,000 square kilometers. That is that. So then life expectancy, if we decide to change it to life expectancy, then we're going to get something different. For the life expectancy now, we need to have it greater than 82. So this is greater than 82, greater than 82. So chaining commands with pipes, same as our normal data frame using the dplyr function. So everything is just the same thing. Let's have a look at that 7. So if you have any question, please kindly put it in the box, the chat box. So mind you, next session, that's next month, we're going to look at the raster data object, the geometric spatial objects. So we're going to look at that next session. So for now, we're looking at the normal SF objects. So this simple feature, the vectors, we're looking at vectors this time around. It can be multi-polygon by points, lines, and so on and so forth. So, so an alternative to piped operation is nested function call. So instead of piping, we can nest within each other. So we can use this, we get the same results. So what 8. So we have 5 rows and 3 columns with the sticky column. So another alternative is to split the operation into multiple self-contained, just reassigning to different different variables. then we now combine them to work with each other. So here we created the world data set based on the filtering operation that we do here. The next one, we use the results of the filtering that we did and we place it. Okay, there's a question. Others see you implement. Oh, okay. Yeah. So yeah, that's okay. That's brilliant. Yes, I'm not actually in the console. Yeah, sorry. Yeah, I'm using the document, a file type in R that we call Quarto. So this allows me to have both text and my code chunk in the same document. I can't get away with all this without commenting in my normal R script, which will now show you that, okay, I'm running within the console. Actually, all the codes in the code chunks, they are running in the console. As you can see in my R studio, I mean my console, sorry. Okay, they are all running in my console, all the code chunks. The advantage of me using the Quarto document here is that I can also read out some summary from what I've read from the book. I can share that with you as well. And so if you go to the repo, the GitHub repo, you'll be able to see all these explanations summarized from the book itself. So I hope that answers the question. Hassan?
Hi, how are you?
Okay, have I answered your question?
Yes, my question, I see you, yeah, I see you implemented
Yeah,
this order in, not in console. How can I do
yes.
it?
Okay, yes. Okay, let me just try to bring up that document, show you how I created this. So the code chunk is here. So any code that I run in this document is going to be run and shown in the console, although you can see the results in the document itself. So, but this is how you can create this. If you are working in R Studio and you have Quarto installed on your system and it's available in R Studio, all you need to do is either you go to File, New File, then you go to Quarto Documents. So that's what I'm using here. Or just like we always do, we can click this plus sign and we have a drop down, then we have the Quarto document as well. So this is going to give me a pop-up. Just you can give it any title, my Quarto. Okay. So you can give the name of the author as you like it. So, and then you have a document like this. So you can see if I take out everything here, I can start from afresh. So I can start with a heading, add a header, my title. Okay. I can change those from within here. So, and if
Great.
I want to add a code chunk inside the same document, I can just go to insert executable cells. It can be any of these languages. Any of these languages, R, Python, Bash, SQL, anyone. So in this instance, I want to add R code. So I can copy any of this code and just place it inside that document. Okay, and it's going to run. So although now what I have here, I don't have some the what is it? The library is not here, so it's might not work. So it's not like I would have in maybe an ordinary script, so that it's having everything in my environment and I'm able to see stuff. So here you would have to, because after this, I can convert this document, this Quarto document, to any document that I wish by rendering it. So here I want to convert it to an HTML format. It can be PDF, it can be HTML, it can be a Word document. So whichever ones, all you just need to do is click on the render and it will convert to this. So just kind of a side help there. So if I take you to my browser, so you should be able to see something here. I don't know. Okay, I'm coming. Let me just bring up the one that I've done. Getting something here. So let me save this. I'm having HTML, then I can render that. I should have an HTML document here. Let me see 3 that is there. I still want to see what I have in. No, it shouldn't be here. Okay. Okay. Let me show you inside. I don't know why it's misbehaving, but this is the document in my art studio. I don't know if you are seeing my art studio. This is the HTML document. So if I click on that, open view in browser, I'll take you to my browser now. Should be able to see that as a new tab after my main document. So I have everything here, everything inside of this that is being loaded. So if I don't know if there's an error on my document, it should have updated it. So that is how you create the Quarto document, and you can run your code there and also get everything together. So let me see. Processing attributes. Okay, I think there was, okay, yeah, there's an error there. So I need to comment that out. It's an example, but it's disturbing the rendering. So let me just comment that out and re-render. Hope we don't have any other bug anymore. Okay, we're still having some things there. I'm coming. Okay, it's up. Okay, so let me take you to my browser now. So now it's been able to render everything. So it's updated the documents. So these are all my own jottings, my summary of what I've read in the book. So it has all the functions. I can decide not to show all this information because it's getting too long. So, but that is not what we're looking at today. I just want to answer your question. So everything, the code, the output, everything is here. So I'll go back to my art studio now. So I hope I've been able to get that across. So Hassan Idris. So do you know how I got here now? Okay. Okay. Okay, so we're good to go then. So where were we? I think we stopped here. The slicing of, okay, filtering, yeah. So chaining commands with pipes, we've done that. Then we've talked about breaking the execution of the pipes into small chunks that we can now combine and use together. So that is that. So vector attribute aggregations now. So aggregation involves summarizing data with one or more grouping variables. So typically from columns in the data frame to be aggregated, not the geometry column. So here we want to aggregate using the aggregate function. So the population for the component, the continents, we're using the function sum. Then the data set is this. So then we're removing any NAs. So if we look at the output now, let's just view that. So we're having two columns. So for each continent, this is the population. So for each continent, so a continent can have multiple countries that are there. So, but for each continent, now it's more or less like we're grouping and summarizing. So we're going to get there. So that is what we have now. We have 6 continents, and these are the total population that we're having for each one of them. So if we look at the class, it's just a data frame. The spatial or geospatial aspect or geographic aspect data is not within this because we've already done an aggregation, which is not going to involve the geometry column. So the result is a non-spatial data frame with 6 rows, 1 per continent, and 2 columns reporting the name and the population of each continent. So aggregate is a generic function, which means that it behaves differently depending on its input. SF provides the method aggregate.sf, which is activated automatically when X is an SF object. In this case, we're looking at the world data. So, okay, is an SF object and a by argument is provided. So just like what we have here is going to be what? So if we run this line by line, we're having the aggregate here. Okay, sorry, I have another. How do I join my data to the SF or make it an SF object? I actually went over that. Okay, let me show you. Okay, if we're having a data frame, let's see. I don't an example that I want to give now. So, but I'll show you the example that I did earlier. So this is more like let's try and create a new data frame here, just like we have it here. And so I'm going to create a new data frame that doesn't have the geometry column. So I'll say that's going to be my DF, assign it to this. So I want to also use a column population is equal to, I'm going for the column pop from the world data set, that's the SF object. So if we look at what we have here, this is going to be an ordinary data frame because I'm pulling data from each column for some certain columns from within the world data frame. So class now, DF, so that is going to be just an ordinary data frame. Okay. So if I want to merge with or combine it with maybe the world data objects, or I want to convert it to an SF object, I'll use this function. Okay. I can use this function. So it's going to give me that simple feature attribute. So I can decide to say, for each of these rows, okay, I need to have a column which is going to be the serving as the geometry column. So if I run this, you see this is a geometry column with features. But in case you don't have this, I don't have an example here now. What you can do is this: if you have maybe a data set with a latitude and longitude column, you can convert that. If you watch our previous video, you can convert those 2 columns to a geometry column. Okay. So you can convert it to a geometry column, combine it with your simple data frame, and use this function. Maybe you have a data frame that contains cities, they need to have the latitude and longitude values, or maybe columns. We combine those two together and then we'll be able to use that. But I don't have an example here, so I won't be able to do that now. So, but if you watch the previous videos, you'll see an example has been done there and you can follow through. So that is going to be for that aspect. So, but for this one, I have this. Using this function, I can take this, copy this, drop this here, df, reassign it or override what is there before. So I can just take this out. So I just put df that was here now and add this column. Since they are having the same number of rows or dimension, dim df. So they have the same number of rows. So I can still use this column. Okay. So let me just use that. Then now, if I check the class of df, so I'm going to have the simple features properties attached to it. So this is what I can give for this session. I don't have an example here. So that is how you can fix that up. So you can just merge or combine, even if we're going to do something like that, inner join and all this stuff. So just hold on. So, but if you have an ordinary data frame and you're looking at converting it to an SF object, this is what you do. Then if you're going to merge with another data set, let's see what we can achieve today for merging something like that. So we're going to get there now. So moving out of the aggregates, so you can do the same thing, the summarize aspects. So let's go. We can breeze through here. It's just the same thing as what we do with dplyr. So you can combine what we have learned so far about dplyr the same way we do with ordinary data frame by chaining the multiple commands to summarize attributes data. So about countries worldwide by continent. So that is what we achieve here. So if you go through this example, you'll be able to see the output. So world, so I think I can see it here, 5. So if you take a look at that, we'll have that. So it's based on all the statements that we'll get in this. So Africa is here. So we have all the new columns that were created within the summarize function. They are here. So joining now. So I believe you might have a clue here about joining your data with an SF object or creating your own geometry column. So moving on, dplyr join functions work the same as we have on data frames. So to demonstrate joins, we will combine data on coffee production with world data sets. So coffee production data set is just an ordinary data set. So the coffee data is a data frame called coffee underscore data that comes with the SP data package. So we can explore that by just selecting that or copying it. Let's drop it before our statement. So if we look at that, we have just a table with 47 rows and 3 columns. If we look at the class, coffee data. So if you look at the class, it's just table data frame. It's just an ordinary data frame. So now we can do a left join. Okay. So the left join is not taking an extra argument because there is a similar column or variable between the two. That's the two data sets, the world data set and the name and the coffee data set. So that's the name underscore long. So if I select the world, you have the name underscore long there. So this is where we're going to achieve the joining. So the left joining means that everything in world will still be there. Then we'll combine that we combine data from the coffee data to it. So if we do this and we save it as world underscore coffee, we'll be able to get something. So we are joining by default using that name long. So, but you can also decide to put the comma and add the by argument. So, but that's not necessary because it can detect it by itself, provided the name and the type are the same. So that is that. So we can look at what we have. So we have 177 rows, then 13 columns now. So if you look at the class now, because we have world data as an SF object, it invariably transfers that to the blank or ordinary data frame that is joined to it. So that sticky situation still goes with it. So you don't leave me behind. We're going together. So that's what the geometry column does here. So it gives it back the SF object as well. So because the input data sets are okay, share a command, I've explained this. So you can learn more about the function left underscore join using the question mark index. So that is for that one. So we can also look at this, the names that are now in the data sets. So we have all these names and we have the geom column still available. So we can now use this data set to plot because we have the geom column, so we can easily plot it on a map using the plot function. So moving on, in the majority of cases where variable names are not the same, you have two options. So you can rename the column or the variable in one of the objects so they match, or use the by argument to specify the joining variables. That means we're going to equate. For the second option, we're going to equate it, even if they are having different names. So let's take this as a new data set or data frame because we're going to rename that column name underscore long. We are just making it up that, okay, we want to rename it. So now we have this. So if we're not going to join this, now they don't have similar names. Okay, so if I select this, run this, now we have NM instead of name underscore long. So for this function to do its work or perform the miracle that it's going to do as a function, all we need to say is that, okay, left join, do your work, but note that name, using this helper function, name underscore long that is in the first data set, that's the one we are joining to, is actually equal to the column name in the data set that we are joining. So that helps it to figure out, okay, oh, the names are just different, but they are the same thing. So if we run that, we're going to get similar to what we had here for this data set. So moving on, any question? If you have questions, just put it in the chat box or just signify, and I'll allow you to ask your questions. So going back to what the book says, note that the name, okay, this, I've explained that. So the name, okay, this, what is happening now is that the name in the world that the data frame, the data, that's the world data frame, or data object that we are joining to will override the name in the data frame that we're joining. Okay, I hope that solves it. So the name in the word data object will be the one that is going to be referenced, used for the column while we're going to drop this, the name. So that's why you're having this name long instead of NM, or and name long combined with NM, nothing. So that is that. So what if we only want to keep countries that have a match? Okay, there's something that was noticed here. So although there are 47 rows of data in coffee data, all 177 country records are kept intact. And that's exactly what left join does. So automatically, wherever the values are not matching, is going to be an NA. So, but the number of rows in the first data set is going to be what is going to be maintained. So even if this is more than 47, the number of, okay, is more than 177, the number of rows here will still remain. So it's not going to be more than that. So for left join. So that it's, but anywhere the missing values or values are not available that is matching, is going to be NAs. So what if we only want to keep countries that have a match in the key variable? In that case, an inner join can be used. So that is what we're going to use here. So it's only going to return whatever is available in both data objects. So let's look at that. So there's still kind of an issue here, because instead of having 47, we're having 45. Okay, so we're going to look at that. So number of rows is 45. So note that the result of the inner has only 45 rows compared with 47 in coffee data. So what happened to the remaining rows? I don't want to say preempt that. So we can identify the rows that did not match using this function setDiff. So this is what we're going to, you will call up the two columns, okay, from the two similar columns from the two data sets. So, but we're going to put first the one that we are actually concerned about. So we run that, we'll see that there are two rows or two values that are missing. So that is going to account for the rows that are missing now. So instead of 45, we have 47. So the result shows that others accounts for one row not present in the world data set, and that the name of the democratic accounts for the other. So it has been abbreviated, causing the join to miss it. So now the following command uses a string matching, that's regex function, from the stringar package. Also, this package belongs to the tidyverse family of packages. So we're going to use that to help us in this situation. So if we look at this function is going to help us to subset this value from this column. Let me drop that. If we use the help str underscore subset. So this is the documentation. So you find matching element. So this is a regex that is going to be used for the matching, and we're going to get that out. So if we run this, okay, so we'll get that value. So to fix the issue, we will create a new version of coffee data and update the name. So this is what we're using here. We're using another grapple. So this is a function that helps us also to do something similar to what the stringar package functions do. So it takes in this value. We're looking for Congo. Oh, sorry. Control Z. Okay. Z again. Okay, I think I get it. Okay, so this is what we're going to be looking at. So we are assigning this value. We're subsetting here. We're looking for, we're going to look for this row that matches this for this column. So if I take this, I should, okay, let me just copy this to the okay, I didn't copy the entire. So if I run this, they're expected in this. Okay, I don't know where the error is coming from. Okay, okay, I think I still had something missed. Okay, let me see if I can run the entire row. Okay, it went. So what would I get with this one? Name this, and this. Okay, so what we're looking at is this. If we look at this coffee data set, let's just look through. We're looking for that. Okay, it's just one. No, shouldn't be one. I don't. Okay, it's moving. Previous. I want to get to see where we can find Congo now. So let's see. Congo is not here. It's not here, and it's not here. This is actually supposed to look for, we're looking for this column using this kind of regex statement, okay, for the row, and we're referencing this column. So I'm expecting that should, okay, yes, that's why we're getting, okay, sorry, live coding. Oof. So that's why we're getting nothing. There's nothing like this here. So for us to be able to assign the value here, we need to assign this variable, the value in this variable, to this column based on this value. So let me just run this. Then we'll look at coffee data again. Okay, let's look at that. Then we have something here. So that means before we did this, we actually, so I would have missed that for the first one. So let me just see. Let me see. There's one coffee data renamed that we can look at. Okay. Okay. Yes. That is it. This is where it is. So that was okay. I missed that while looking at the column. So this is where it finds the Congo and now change the name to match what we had. What is in the word data object. So that is what I'm trying to explain here. So this is going to help us to do like a wildcard or reject statement that, okay, whichever row you find this for this column, replace it with this. So that is what we're assigning to it now. So that's why we're having this new value here. So now we can do a new inner join. So, and we look at the number of rows now, it should be what we needed, something that, so it's about the mismatch of the names. That's why we're having these two rows. But now that we've resolved it, we're having one for the coffee data, and we also have one for the word data. So now that we've combined the two, we're able to resolve it to have only 46 rows where we have a match. So that is going to be where I'm going to stop for today. So I have another session. So we're going to continue with this next class. So if you have any question that you want to ask me based on what we've dealt with today, I will be available now to have it, because I'm going to have a meeting by 6 p.m. Nigerian time. So any question? If you have any question, just let me know. But basically, data operations here, working on attributes other than the geometry column is just similar to what we have for ordinary data frame or our normal data frame. So that's basically it. So if you have questions, let me know. So if you don't have questions, I think we're going to have to round up here. So I'm going to add the remaining aspect of the chapter to the video. Then we're going to upload it onto YouTube. That's for the Abuja R User Group YouTube channel. So you can watch the recordings there, and for the previous ones, you'll be able to catch up with what we've done today. So thank you so much for joining me. Thank you, Hassan, Idris, Mada, Bolli. Sorry if I miscall your name. So thank you so much. And okay. Okay, thank you. Thank you. I'm grateful. Thank you. So till next session, we have another study session coming on Saturday. That's going to be for R for epidemiology. So if you have the time, you can join us for that session as well. So thank you so much, and God bless. Goodbye.